All right, so on 128, this one, you had to solve for k first. Determine the rate of learning k. This is kind of like that blood alcohol concentration problem we did. It's the same steps as that. It gives you enough information that you can plug it in and then only have k being the unknown variable. So it says a is 200. So I'm going to do 2 for a. The L then would be 20, because that's how many words we run, 20. And then we've got 1 minus e to the negative k. And then t would be 5 minutes. So to find k, that's how we start. 20 equals 200 times 1 minus e to the negative k times 5. So then we're going to divide both sides by 200. That gives you 0.1. This side you got 1 minus e to the negative 5k. You just rearrange that extra a little bit. And then it's going to be the same steps where we subtract 1, that gives you negative 0.9, and negative e to the negative 5k. But then you got to get rid of the negative, so we divide both sides by negative 1, we get positive 0.9, equals positive e to the negative 5k. And then natural log. Natural log of 0.9 is negative 5k, and then we divide. K is natural log of 0.9 divided by negative 5. Be your k. That's the first step and the hardest step there. That gets you 0.021. Okay. And then what we do is we now have our new equation. We use this new k for our equation. So now L of t is a times 1 minus e to the 0.021 t. And that's going to be the equation we use. So then for part B, how many words in 10 minutes? We're then just going to replace the t with 10. So we'll just plug it in. L equals 200 with 1 minus e to the negative 0.021 times 10. We're just going to plug that into our calculator. You don't really have to do any solving on that step. Negative 0.021 times 10. So we get 37.88. And then we did the same for 15. We just replaced the 10 with the 15. And we get 54. And in the last step, we're going to solve for t, because it's asking how long. So 180 words would be 180 equals 200, 1 minus e to the negative 0.021 t. So we're solving for t. And so we just go through all of our steps. We divide. We subtract 1. We divide by negative 1. And then we natural log it. And then we divide by negative 0.021. And you should end up with 109.6. And that's minutes. For that one. So just go through your steps as well. Oh, really? If you just did 0.02? Okay. Any other questions? So today we're not going to do any word problems. Today is going to be a little bit more like, what should we say, sort of algebraic, but we're still going to look at logarithms today. And it turns out logarithms have like some unique properties that other functions don't have. So that's what we're going to check out today. We'll look at these the next couple days. Today we're just going to look at mostly how this affects numbers, logarithms. So there's 7 of these. You will probably want to write them down because you have an assignment where you actually have to like list out what the properties are. So make sure you're familiar with them. Make sure you I would write these properties down. We got 7 properties, and then we'll use them to solve some problems. All right, so let's start with our first property of logarithms. And we'll do an example that you could use to figure out what these answers would be. So our first one is log base A. A is just some constant that could change. It could be 5 or 10 or 12 or whatever. Log base A of 1. So there's an easy way we could figure this out with your calculator. If we had just log. What is log the base of? Yeah, log base 10, right? So if you did, say log, just log base 10 of 1, you can do that on a calculator because log is right there. Log of 1, and you get 0. Okay? So any base with a logarithm will actually give you 0. And it should also make sense if we remember what the graph looks like of the logarithm. Remember how the logarithm passes through right there, or any logarithm that passes there at 0 and 1. So that should make sense that the 1 comes 0. If the x is 1, like the y is 0, so that works, right? Okay, so the next one, log base A of A. So this would be something like log base 3 of 3, for example. What do you think that equals? Yeah, 1. Yep. Most of these are pretty easy because they're just whatever your intuition will tell you. So log base of 100, log base 100 of 100 would be 1. These sort of just cancel out and leave it just 1. So any base, if the base and the number are the same, you get 1. Okay, how about log base A of A to the R? So let's say, for example, log base 3 of 3 cubed. Lots of 3's there. What do you think that equals? Probably 3, right? These cancel. And left just the 3. That just equals whatever the R is, whatever the exponent is. This one is actually really the same property. There's just an invisible 1 there, so these cancel into just the 1. Really the same property. Okay, and one more here. If you have an exponential raised to a logarithm, and m is just representing, it could be a constant or a function, but a to the log a of m, what do you guys think that would equal? Probably what? Yeah, these cancel. Well, the a and the log a cancel. So just m. Because you need a log with exponential. So like this one, the log a cancels the big A. And that's the log a. Those are inverses. So you need a log with the same base to cancel an exponential. Yeah, sure. So let's say if you have 4 log 4 of 10, the log 4 and 4 cancel into just 10. So those are the easy properties. The ones that you could, it just seems like it would be whatever it is. And now there's 3 more. These ones take a little bit more work. And we're going to prove these properties as well. All right, so the first one is log base a of mn. And this is really a times. There's no multiplication symbol, but it means multiplication. Right. So here's what we're going to do to prove it. I'm going to say log of 10. That's the same thing as if I were just kind of want to write it like this. If I said log of, let's say 5 times 2. It's the same thing, right? Kind of like writing it like that. Right? Log of 5 times 2. It turns out that this is the same thing as log 5 plus log 2. And if we did this on our calculator, we just tried log 10. You actually only get 1. And then if you do log 5 plus log 2, you get 1 as well. So this property says that if you have two things multiplied inside of a logarithm, then you can actually split them up with an addition sign. Log base a of m plus log base a of n. So if it's multiplied, you can split it up into addition. Right now, you don't need to worry about why you would necessarily want to do that. But it works both ways. You can also take an addition, you can bring it together in a single log by multiplying. We'll practice that a lot tomorrow. Okay? And here we just proved it. These are both 1. This one. All right, so the opposite of that would be division. If I have a log base a of m divided by n, based off of that precedence there, what would you think would be the case? Yeah, be subtraction, yep. So this would be log a of m minus log a of n. So addition, multiplication are pairs, division and subtraction are pairs. And I can show you this one how it works too. Let's do the same log 10. But if I were to write this as a division problem instead, let's say I wrote this as something that equals 10, let's say 50 divided by 5. That's the same thing as 10, right? And then so this should work if I do log 50 minus log 5. That will equal 1, and you can try it out. Log 50 minus log 5 and you'll get 1. So kind of neat properties there, right? Doesn't seem like that should be the same, but for whatever reason that is. Right, and one more. This one is if we have something raised to a power. It's our last property. So like if we have log, I'm going to use a variable because this is where you mostly see it. Log x to the 5th. Turns out we can take that exponent and we can bring it down in front. And we can write this as 5 log x. Bring that in front. And so when you do this, you can bring the r in front. This is r log base a of n. You can bring exponents down in front of logarithms. And like a numerical example of this would be like, so let's say we have, so you want to do a log of 25. Well, log of 25 is the same thing as log of 5 squared. This 5 squared is 25, which that means that's the same thing as 2 log 5. You can bring this down in front. And again, if you tried that, you try log 25 you get 1.39. And if you do 2 log 5, you'll get the same answer of 1.39. So all of these are easily verifiable. So these are 7 properties that you do have to know. You're not going to be given like a formula list or something. You got to know these. But we'll use them a lot, so you'll get to understand them. Well, let's do a few problems. Most of these are pretty easy, as long as you just know the properties. Start off with a really easy one: log base 3 of 3 to the 71. And all of these you can do without a calculator. You'll also get just like a single number for all these as well. So what's the first one? Yeah, we want log 3 of 3 cancels. 71. Okay. What's natural log of e to the negative 4? Yeah. Remember natural log of log e. Two easy ones to start. Alright. 2 log 2 of 7. So an exponent raised to a log with the same base cancels, right? So just 7. Okay, those were the super easy ones. Now just a little bit harder. What's that? Yeah, it'll end up being 1, it turns out, yeah. So the first thing you need to do is to condense this into a single log. When it's addition, we can bring this together as multiplication. So we'll write this as log 8. And then the numbers here, we can multiply those. 2 times 4, which is 8, right? So then we got log 8 of 8. Which is 1. Someone made the suggestion second period that instead of writing 1 from now on, you just write log base 8 of 2 plus log base 8 of 4. And then say 1 like that. So try doing it. See if you said it correct. A little more complicated way of writing more. All right, log base 6 of 18 minus log base 6 of 3. Yeah, turns out it's 1 again, right? Here's another way to write 1. You try this way. Prefer this. First thing you want to do is bring it together because it's subtraction. So subtraction is division. You write it as 18 over 3. The same base of 6. Now notice these do have the same number here. I think I have the same base. So that's log 6 of 6, which then is 1. Very good. All right. Now this next one is a bit tricky. I think the book kind of throws one at you that maybe it's a little bit too hard. But we're going to do this nonetheless. One thing that you'll see is that the bases are not the same. Okay, that's a 2 and that's a 6. And this is not a property that we've actually seen yet where we've multiplied logs. We've seen if this was like a plus, then you could bring these together as multiplication, right? But you can't do the opposite. You can't say if this is multiplication. You cannot say this. You can't say it's like 6 plus 8. That is not a property. You can do from addition and then condense it to a multiplication, but you can't do the vice versa. And they don't even have the same bases. The only thing we've really seen with a multiplication is this property, where this ends up being like r times that. Okay, so this is actually the property we're going to use here. And it's not so obvious, like I said, this is a little bit too hard of a question, I think. So this is multiplication, and we're going to try a couple things. I'm going to first try to, basically look at this as the exponent, and then to take that to the exponent up there, and see if that works. So log 6 of 8, right? And then take this whole thing as the exponent. Log 2 of 6. And see if this will work. We should get something to cancel if this is going to work. But, like in particular, it'd be good if this stuff canceled or something. But this is a log base 2, and that's an 8, so actually it doesn't cancel, unfortunately. If you try this the other way around, though, since this is multiplication, you could really just rearrange this equation. Log 6 of 8 times log 2 of 6. Look at it this way. And then try the same thing. Now try to take this one up there. And write it this way. Log 2 of 6 to the, that's our exponent. Log 6 of 8. That seems to work, right? And then so what happens here, we got 6 to the log 6, so those cancel. And we're left with then log 2 still, so we got that log 2 of 8. Those things cancel. You might think, well, I don't know what that is, with log 2 of 8. But think back to the log properties. You remember what that is? Remember how you evaluate and we say this to what power is this?
That was a 3.
Yeah, it's 3. It's 2 to the third power is 8. So this is just 3. Again, that one's a little bit too complicated, I think, but don't get too concerned if you can't figure that one out yet. I think I got one more here, and then you'll have some problems that are really similar to this. 3 to the log 3 of 5 minus log 3 of 4. So what do we want to do first on this one? Do what? 3 times. No. You mean 4 times 5? I don't know. Do something big.
That's 7 1. So divided.
Yeah, so these are subtraction, so you can write this as division. So we'll keep the 3, log 3, and then subtraction means division, so 5 over 4. So the minus turns into division with the same log base. And now, we got something good, right? 3 log 3, that cancels. Anything that looks like it cancels generally cancels. General rule. And then so we just got 5/4 left. That's our answer. Tomorrow we'll use these properties with some more practice where we'll like condense and take these apart. We'll do more practice with that. Today I want you to practice more like how the numbers function. And so you've got some problems and a good amount of time to work on them. And here's the assignment. It's on Google Classroom. And you can work with someone if you want to. It seems like there's a lot of questions, but the first 1 to 10, I'll pull those up real quick, are not bad. Like most of them are just recopying what the properties are. So 1 to 10 is going to be just like some properties, and then there's some true or false questions. You can just try your best to answer those. You got 3 true or false, and then you've got some like we just did where you're trying to solve it without a calculator. You get to a single number. Number 7 is kind of confusing. Don't worry about this one. You can answer it. It's just actually 7, but